Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment on two sample proportions. We're going to run a two sample confidence interval. And the scenario is your hands are dirty. So, hand hygiene is one of the most crucial practices in preventing infections in hospitals. A metropolitan hospital with 4,500 medical staff members work during the day shift and 3,800 work at the night shift. Okay, so in this case, we have two populations. This looks like population one for the day shift, and here, population two for the night shift. So this is day shift population, night shift population. And they're investigating whether compliance with hand washing protocols differs between the shifts. Hospital administrators have observed that anecdotal evidence suggesting the staff members on the night shift may be less likely to follow proper hand hygiene procedures due to the reduced supervision and increased workload. To formally assess this, the infection control team randomly selects 300 medical staff from the day shift. Okay, so we have a random sample of 310. So this is our sample size from the day shift. So I'll mark that as N1 for day. And 280 staff members from the night shift. Okay, so we have a random sample of 280 for the night shift. All right, so that'll be N1 and N2's day shift and night shift. During the day shift, 275 out of the 310 sampled members were observed complying with hand washing procedures. Okay, so this will be our X. So 275 will be our X1. That'll be our day shift, those who comply. And during the night shift, it was 234. So that'll be 234 will be our X2 for our night shift. So 234 complied on the night shift out of the 280, 275 out of the 310 during the day shift. Okay, so it says use a 96% confidence interval. All right, so there's our confidence level to estimate the difference. So we know we're subtracting in compliance between the two shifts. Well, this is our formula. So, we're going to use let the one equal day shift and the two is night shift. So the proportion who complied during the day shift minus the proportion who complied during the night shift, plus or minus Z star. And then we have day shift, one minus the day shift over the sample size of the day shift. The proportion of the night shift that comply, one minus the proportion of the night shift over the sample size of the night shift. All right, notice it's a confidence interval, so we're using a p hat because we use p hats anytime it's a confidence interval. All right, well, when we collected our data, the one thing we noticed is we had 275 and we had 310. 275 complied out of the 310 sample size on our day shift. And on our night shift, 234 complied out of the 280 sample size. But what I don't have is I don't have p hat 1 and p hat 2. So we're going to have to calculate those. So p hat 1 equals x1 over n1. So, and that's what we have written right there. So we can just go 275 divided by 310, and we get 0.8870. We're going to go 4 decimal places and call it good. And for p hat 2, it's the same formula, but we're going to use x2 over n2. So this case will be 234 divided by 280, and there it is, 0.8357. So we're good to go there. Now that we have p hat 1 and p hat 2, the only thing we're missing to run the confidence interval is our z star. So we're going to have to calculate z star. Well, z star is just going to be simply, hey, second vars, inverse norm, parenthesis 1 minus 0.96, close the parenthesis, divide by 2. It's a z, so we're working with a mean of 0, standard deviation of 1. and we have a negative, but we're always going to make it a positive, and so we'll have 2.0537. So once again, inverse norm, 1 minus 0.96 divided by 2, a mean of 0, a standard deviation of 1, and we're coming from the left, and we want to make sure our z star is positive. Once we have that, we can plug it in. So once we plug it in, kind of messed up here. That's all of our information. P hat 1 right here minus P hat 2 Z star 2.0537, and then P hat 1 minus P hat and times 1 minus P hat 1 all over N1. Then we have P hat 2, 1 minus P hat 2 all over N2. All right, so that takes care of that. We know we're running a two proportion Z interval. All right. Well, when we go to graph this thing, we're graphing it and we're going to graph it on the difference. So we're going to graph it on P hat 1 minus P hat 2. So we go, where did that 0.0153 come from? I'm so glad you asked. So if we take 0.8870 minus 0.8357. So 0.8870 minus 0.8357. That equals the 0.0513. And we know that we want this to be 96% or 0.96. So that's what the space is going to be in there. Well, at this point, we can go ahead and run this test. And let's go ahead and get the interval. So stat test, one proportion Z interval. We're going to have to scroll a ways. Excuse me, two proportion Z interval because we have two different proportions. X1 was 275. N1 is 310. X2 is 234. N2 is 280. And we need a 96% confidence interval. And there it is. So negative 0.0072 is my lower bound. And we have an upper bound of 0.10996. So there could be just below, not even very, very small percentage, not even 1% that the night shift does more, to almost 11% that the day shift does more. And the reason I know it's positive is, or that's the day shift, is because I went with a positive number. All right. 275 minus 234 is a positive. So consequently, this must be day shift has more or looks more, but zeros contained. So really, we don't know what the difference is. So anytime we have two measures, just like when we had two measures for the t-test, we actually have two parameters here. So our parameters in this case are going to be let P1 equal the true population proportion who wash their hands for the day shift, and let P2 equal the true population proportion for those who wash their hands for the night shift. Okay? Because we have two parameters, we have to have two sets of conditions. We're going to have a day shift and a night shift. So we randomly selected of 310. That was our sample size, and that was given to us. So we can go ahead and write, all right, random select 310, given, check it off. We also randomly selected 280 for the night shift. So that was given. We're good to go. Okay, we need to check to make sure our populations aren't, and we have to have independent random samples. So every single time we have two independent random samples, whether you label it as two or just include it as the first one, you need to make sure that you include the independent sample. All right, because we have two independent samples. Next thing, we need to make sure our sample size isn't too big. So we're going to go 310 times 10 is 3,100. But our population, when we look back over at our initial scenario, and I'll bring that down here. Our initial scenario said, hey, we had a population of 4,500. Well, in this case, 3,100 is less than 4,500. We're fine there. Here we have 280 is less, 280 times 10 is 2,800, and our population size happened to be 3,800. So we're good there. N is less than 10% for both of them. And really, that's what we want to start saying. All right. Then we have make sure, this is super critical when you're making sure that it's big enough that you're working with p hats. All right. We're not working with the population, we're working with the p hats. So, and when our p hats came from up above, so we see 310 times p hat 1. And that ends up being 274.97, and that's greater than 10. Okay, but then we have to check the 1 minus and 1 minus. So we're going to go 310 parenthesis 1 minus 0.887. And we get 35, and that's also greater than 10. So this one's big enough, but now I need to check the other one. Well, p hat 2 is 83.57. So here we go. 280 times 0.8357, and we get 233.96 greater than or equal to 10. Good to go there. And then 280 parenthesis 1 minus 0.8357 is 46, and that's also greater than 10. So in this case, we know that our sample size is large enough. It's not too big. We check that here, and it's less than 10%. And here it's big enough to be normal. So what are we? Well, we're 96% confident that the true population proportion difference between day shift hand washing and night shift hand washing lies within our interval here. Now, that's all you have to do with that. And for the next one, and by the way, you may need to make sure that you include the word difference. In repeated sampling, we expect this method to capture the true population proportion difference for day shift minus night shift hand washing 96% of the time. All right, I hope that helps. Look forward to seeing you on the next one. And that was two sample confidence intervals for proportions, or two sample proportion confidence interval. Thank you.